Identify the local and absolute maximum and minimum values for the following function. So when you're asked to identify the max or minimum values, it's important to note that the value is actually the y value. So we're actually asking for the y values here, not the coordinates. So let's start with the absolute max value. So we're looking for the largest y value over this entire domain. And you'll notice that the left endpoint here, because there's an open dot here, we don't actually have this value in the domain. So although this is the highest point over the entire graph, because of the open dot, it's not in the domain of the function, so we don't actually have an absolute max value. Because that y value, or I should say where that y value occurs, it is not in the domain, therefore that y value is not in the range. So that's kind of an interesting one. There's no absolute max value. Now let's look for the absolute minimum value. So first let's identify where the absolute minimum is on the graph. So the smallest y value, which would be the lowest point on this entire graph, occurs at this corner. And so that coordinate looks to be 1, 2, 3, 4. That coordinate looks to be 4, 1. But again, we're looking for the y value, so the absolute minimum value would be 1. Now, if you were asked where does it occur, you could say that this absolute minimum value occurs at x equals 4, if you were asked where it occurs. But in this case, the way this problem's worded, if they just want the absolute maximum value, then you would just give an answer of 1. All right, let's move on to locals. Let's start with local max values. Notice I said values, plural, because there could be more than one local maximum. So looking at the graph, where do we have those high points? Where do we have y values that are larger than the other y values around it? So it looks to be a high point here. That is at 1, 2, 3. It looks like at x equals 3. So that coordinate is 3, 4 is the actual ordered pair. The y value there is 4, and that y value is bigger than the y values around it. So one local max value would be at 4. Again, where does it occur? If you were wanting to write where it occurs at x equals 3. But the actual max value is 4. Then searching for other high points, it looks like we have another high point here. And that looks like that is the coordinate 6, 3. So we have a second local max value of 3. That's the y value. And again, it occurs at x equals 6. Now, you might be looking at this kind of odd spot. Let's just talk about it for a second, right here on the graph, where we have this open dot right there. But again, remember that the actual y value there, when x is equal to 2, the y value is actually 2 because of the solid dot below it. So that is not going to be considered a maximum in this case because of that open dot. And lastly, let's go on to local min values and see where those may occur. So the first somewhat obvious minimum is the one we already discussed, which was the absolute minimum that occurred at 4. So it's occurring at 4, but again, the y value there was 1. So we have a local minimum. The local minimum is 1, and it occurs at x equals 4. And remember, that point, it was also the absolute minimum, and that's okay, because that absolute minimum can have two names. It's both an absolute min, and it's also a local min. And then let's look at some other low points on the graph. It's kind of interesting looking back at that solid dot versus the open dot. We have this solid dot here, and that coordinate is looks like 2, 2. And then we have the open dot right above it. And if you take a look at the curve around that open dot, notice that our y value here, our y value was positive 2, and that y value is indeed smaller than the y values around it. So if you look on either side of x equals 2, the y values are smaller than the y value where we have the solid dot. So that means that even though that is just a single dot there alone by itself, it actually does count as a local minimum. So we have a second local minimum value of 2, and it occurs at x equals 2. Kind of a unique situation. You're only going to see that in a piecewise graph like this, where we had that one discrete point and then the rest of the curve around it. But again, it's because the y value at that solid point there at 2, 2, that y value is smaller than all the y values around it here on the curve. That's why that point will count as a local minimum.